All right. We are going to do section 13.3 now. Let me put that right here. All right. Let's start off. Let's use it. We haven't used this thing yet, have we? Not in here. I used it today.
Do you program those things?
I made it myself, yeah, and I put them on there off to the side just so that I could use them whenever I needed to.
Circles like that.
Yeah, I just did that over the weekend, put the circles there. Because we're doing circles in geometry as well, so I thought it would be good to have them already pre-made. Because sometimes I want a radius, sometimes I don't, and I can just grab it, don't have to take the time to do it. Okay, so here we go. We've got an X and Y axis. We're going to do an angle. Let's change some stuff up here. That's not us. All right, and let's have the angle. Actually, I did this last class. Let's do something first. Let's read off the example first, okay, and then we'll set the thing up. This is right from the book. It's an example on page 825. It's a little wordy, but you'll understand when I set this thing up. It says the terminal side. That means that's the angle where it finishes. Remember, we had the angle as two sides actually. No, most of the time we only draw it as one side, but you had one side, going horizontal along the x-axis, positive x-axis, and then the other side, the terminal side, went wherever we're going to go here. So let's read it. The terminal side of theta in standard position contains the points -3, -4. Let's just write those points down. So it's -3, -4. That means our angle goes through that point right there. All right, so where would -3, -4 be? Let's just kind of draw it freehand here. There's -3, there's -4, and then the point would be about right there. Would you agree?
Yeah.
And what happens, our terminal side, remember this is our initial side, it's always along the x-axis, the positive x-axis, but the terminal side is the one that's from the origin, and this one, it says it goes through, and we'll just stop it right at -3, -4. Let me drop that down. All right? It's close enough. All right, so there's our angle right there. It didn't tell us an angle, did it? It didn't tell us how many degrees or how many radians or anything like that. It said that our terminal side, which is this angle part right here, it goes through the point -3, -4. So I went over 3 to the left, I went 4 down, put a point, my line goes through that point. I stopped it there just to make it a little bit easier. Now the question says, write the 6 trig functions of theta. Now where in the world is theta though? Theta is this angle from here all the way to there, right? Because we always start from the positive x-axis. We go counterclockwise until we get to that terminal side, so that angle is theta, all right? Now, the nice thing about this is this is 180 degrees plus whatever this angle is right here. Do you agree?
Yeah.
So I'm actually going to call that theta right there because this is part of our triangle. Because if I did this, now we're going to do this quite a bit. If I took from this point and I made it go straight up and hit the x-axis, I've got a nice right triangle right here, don't I? And I've got this angle. And I actually know a couple sides of this right triangle because I knew where this point was. This point is at -3, 4. So how did I get there? I had to go 3 to the left, right? So what's the length of that side of the triangle?
3.
It's got to be 3. And in fact, we went to the left, so what do you think is important here?
-3.
Right, the -3. So I'm going to put a -3.
And that side's 4.
And then,
-4.
right, and this side is -4. Very good. Are you with me on this? Now, we want to do the 6 trig functions, so hypotenuse has to play in here somewhere, doesn't it? So let's find what the hypotenuse is. They didn't tell us, but we could do that really quick and easy without doing any math.
9.
What is it? Nah, don't even do that. Well, don't even do that. What is it? It's 5. It's 3, 4, 5, right? That's why we learn those special triangles, so we don't have to go through the math and do it. There's only a handful of those that this works with, but obviously they rigged this, right? So to make it a little easy for us. So that right there is 5. Now this terminal side will always be positive, all right? No matter if these are negative, positive, whatever these are, this one right here will always be positive, all right? Because we went to the left, all right? So they're negative because we went to the left and we went down. That's important, all right? It really is. Yeah, because it's not the same like this theta right here. If I did a 3, 4, 5 triangle up here, sine, cosine, and tangent will not necessarily be the same in this as they are down here. Because what are we really doing? We're really finding this angle all the way down. We're not just finding this angle inside the triangle. we're actually finding this angle right here. All right, so the sine, cosine, and tangent of this big angle, the 180 plus whatever that is, the sine, cosine, and tangent is going to be different than the sine, cosine, and tangent of the angle if it was up here in the first quadrant. It'll make sense as we go on, okay? A lot of this stuff, you just have to see it and hear it first, and then eventually it'll sink in the more you do, okay? So let's write down the sine, cosine, and tangent. So we're going to go to the sine of the angle, do the cosine, tangent. Now it says 6 of them, so what are the other 3? What's the inverse of the sine? We have a word for it. What is it called? Cosecant. Good, and we shorthand it like that. And then what's the inverse of the cosine? The secant. Now you would think the cosine and the cosecant and the cosine would go together, but remember what they are. They're what? They're inverses of each other, right? So they're completely opposite. So the sine, the S, goes with the cosecant, the C. You follow me? Okay, they're completely opposites. That's how you can think of it like that. And what's the inverse of the...
Cotangent.
Right, it's the cotangent. We just write it like this. All right. Once you find the sine and cosine and tangent, it's easy to find the cosecant, secant, and tangent, cotangent, because you just flip the fraction, right? That's all you do. They're just inverses of each other. So let's find the sine. The sine of this angle is what over what? Opposite over hypotenuse. This is where it's important with that negative right there. So it's negative, what? 4/5, okay? Because it's opposite over hypotenuse. What about cosine? Cosine is adjacent over hypotenuse, so it's negative 3/5. Now remember, we're not just finding the angle on any 3, 4, 5 triangle. We're finding the angle of a 3, 4, 5 triangle in the third quadrant, all right? So depending on what quadrant that triangle is in, these signs could vary, all right? One could be sometimes it's positive, sometimes it's negative, depending on what quadrant it's in. So we're talking the third quadrant, and that's what's going to happen here. What about the tangent? The tangent is opposite over adjacent. So negative 4 divided by negative 3, what does that come out to be? Just positive 4/3. Look, don't be one of those that put negative 4 over negative 3 and circle that. You wouldn't do that, would you? I see it a lot, though, on tests and quizzes, all right? I don't mark it wrong because it's still the same thing. But look, don't put negative over negative because negative over negative simplifies to positive, so keep it positive. Now watch, the inverse functions are easy. All you have to do, you don't even have to go down here and say, oh, sine is opposite over hypotenuse, so the cosecant is hypotenuse over opposite. You don't have to do that. All you got to do is take this and do what to it? Just flip it, right. Now, you could put 5 over negative 4, but for a fraction, does it matter where the negative is? It could be on the top, the bottom, or out in front, couldn't it? All right. I don't know, for some reason, I just like to keep it on the top. Is that all right? You understand? Because, I mean, yeah, technically it's 5 over negative 4 if you do the inverse of this, but really it doesn't make any difference. It's still a negative fraction, isn't it? And this is still a negative fraction. What about the secant? Yeah, 5 over negative 3. Whoops. There we go. Saved it. So you could write negative 5 over 3 or 3 over negative 5. Doesn't make, or 5 over negative 3. That's what I said, isn't it? Yeah. So you could do it either way. Positive 4 over 3 is the same. If I do the inverse of that, is 3/4. So there you go. There's your 6. It's really not that long. It took me some time to explain it, but for you to do it, it's quick. You just write those down. Sine, cosine, tangent, cosecant, secant, cotangent, and then you just look at your triangle. You'll probably, if they just give you a point, you're going to have to figure out what the hypotenuse is. All right? It's not that hard. On this one, it was easy. Didn't even have to do any math on it, did you? You just put that up there. Okay, so on this one, it was easy. It was just 3, 4, 5, and you just stuck a 5 right there. You're good to go. All right? That's pretty simple, isn't it? So when they give you a point, you plot the point, make the right triangle, complete the triangle with the hypotenuse, and then figure out sine, cosine, tangent, and all that kind of stuff. Any questions on that? All right. Let's go to the next video.